Hi, this week we are working on expressions and equations for the 8th grade. Here are the different standards under the equations and expressions cluster. Notice that everything is continuing to build on each other from previous grades. So we're going to start out with placing values on a number line. So we have 2 squared, negative 1 4/10, and the square root of 9. So I'm going to evaluate each option. I know that 2 squared is 4, negative 1 4/10 is still negative 1 4/10, and the square root of 9 is 3. So I can place 4 on the number line. I can place negative 1 4/10 about where it should go, and I also can place 3 on the number line. Now let's try placing the following real numbers on the number line. I have pi, pi squared, negative 1/2 pi, 3 14/100, the square root of a, and b squared. So I already know that pi is 3.14159, etc. So I can place that about where it should go. I can then place each one of these where they might go, because I know that pi squared is 3 14/100 times itself, so 9.8596, so that's going to go closer to 10. If I took negative 1/2 pi, that gives me approximately negative 1 57/100, so I can place that on the number line. I have 3.14, which I've already placed on the number line. It should be slightly less than pi itself because it's rounded. And when I look at b squared, must be between 2 squared and 2.5 squared, since it's slightly to the left there, which means it must be between 4 and 6.5. So I'll kind of place it in between 4 and 6.5, somewhere between there. The square root of a then, we know the square root more or less than half is what it should be. So then 2/10 times 2/10 is 4/100, and 7/10 times 7/10 is 49/100. So it must go between 4 and 49/100. So even though we can't represent an irrational number as a ratio of integers, we can approximate their value on the number line. And we do know that some numbers are irrational, such as the ones that we just tackled. Answer true or false to each statement. Since irrational numbers continue forever, they cannot be located on a number line. We often use 3 14/100 to approximate pi, but it is not the exact value of pi. You cannot perform operations like multiplying or dividing on irrational numbers. Pause the video, answer true or false to these questions, and then come back. The first one is true, but I'd also say it's false as well. Since irrationals do continue forever, they cannot be located on a number line. We can locate them on the number line as an approximate value. So we cannot put the exact value, but we can approximate them on the number line. We do use 3.14 to approximate pi, but we know it's not the exact value. And we certainly can perform operations on irrational numbers, but we'll need to round or truncate the irrational number in order to use it. Therefore, your answers you find will be approximate answers only. The relationship between a number of movies a customer watches and the total cost is shown in the graph. How much would it cost to watch 11 movies? Well, I see based on the line that we drew here that the cost for one movie is $5. Therefore, the cost of two movies is $10. The cost of 3 movies is $15. And I can plot these points on our line. So 1, 5, 2, 10, and 3, 15 correspond. We're particularly interested in how much 11 movies will cost. If I know that one movie is $5, Well, I know that 1 times 11 is 11 movies, so 5 times 11 is 55. It would cost $55 to watch 11 movies. The cost increases by $5 for each additional movie that we watch. So this tells us about how the values are changing together. If I watch 8 movies per month and my friend watches 5 movies per month, should we each purchase a subscription? So with a Webflix subscription, the monthly cost for one movie is $10 and the monthly cost for 4 movies is $22. If we do not have a subscription, each movie costs $5. Can we come up with a rule to calculate the monthly cost with and without a subscription for any number of movies? Well, I see here that the ratio of $10 for one movie is not equivalent to $22 for 4 movies. So it's not proportional together. But I do see that when I go to the movies watched, I increase 3 movies and I increase $12. So the rate of change is $12 per 3 movies or $4 per movie. So for 8 movies, it would be $38. So $5 for one movie is how many for 8 movies? Well, 1 times 8 is 8, and 5 times 8 is 40. I should purchase a subscription. So $5 for one movie is how many dollars for 5 movies? Well, again, one movie times 5 is 5 movies, and $5 times 25, or excuse me, 5 times 5 is $25. My friend should not obtain a subscription since it would cost less. Can we come up with a rule to calculate the monthly cost with and without a subscription for any number of movies? And I see I have a typo, this should be 25. So y is 5 times x, where x must be the number of movies, and we're increasing by 5 each time. So the rate of change is $12 for 3 movies, which is equivalent to $4 per movie, which is equal to a negative change every time we go down. So I subtract a movie and I subtract $4. So for 0 movies, it would cost me at minimum $6 for the monthly cost. So for 0 movies, it costs $6, which must be the monthly fee for the subscription. This would mean that we would have 4 times the amount of movies we rent plus the $6 fee. For any linear function, the ratio between the change in the output values and the change in the input values is constant. We can calculate the rate of change by dividing the difference in the output values by the difference in the input values. Below are 2 advertisements for 2 companies that sell monthly subscriptions for downloading music. Which company offers a better deal? We have the Totally Tunes, which gives, they claim to give music for less. We pay $5 each month plus a 25-cent per song fee. Or the Groovy Beats is $4.50 for 2 songs or $5.25 for 5 songs. So on the left-hand side, one song would cost the $5 plus the 25-cent fee. If I did 2 songs, it would be $5 plus 50 cents for 2 for 25 cents. 3 songs would be $5.75. 4 songs would be $6. So our general rule is y is equal to 25 cents times how many songs we download plus $5 plus the $5 fee. Now, when I look over at the Groovy Beats, I see that I have 2 songs for $4.50 and 5 songs for $5.25. This is an increase in 75 cents. So the difference between 450 to 475, 475 to 5, and 5 to 525, incrementing between 2, 3, 4, and 5 songs would have to mean that there would be 25 cents in between each song. So therefore, if we go backwards and subtract 25 cents, we would be at 1 song for $4.25. And 0 songs subtracting another 25 cents would be $4. So therefore, they must also be charging 25 cents per song, but their monthly fee is $4. Groovy Beats has the better deal because although they have the same rate per song, their monthly fee is much cheaper. If Robbie worked for 8 hours this Saturday and May gave 6 tours, what amount should Susan write on each of their checks? And would you rather have Robbie's job or May's job? And explain. The student employees for week 1 are as follows. Robbie worked 2 hours while May gave 1 tour. The second week, Robbie worked 7 hours and May gave 4 tours. And then we have the student check employee, the checks for each student employee. And then the positions. The gift shop is paid by the hour, so that must be Robbie since he works by the hour. And the tour guide gets a flat daily rate with additional pay for each tour given. So let's let y equal kx. So if we were to allow k to be his wage times how much hours he works, we could have some of the possibilities here for Robbie. So 21 divided by 2 hours is $10.50. $33 divided by 2 hours is $16.50. And 57 divided by 7 hours is about $8.14. And $73.50 divided by 7 is $10.50. So I'm guessing his hourly rate is $10.50 per hour. Now when I look at May then, the rest of her paychecks must be, the leftover paychecks must be what she gets. So we could possibly use y equals mx plus b because she gets a flat rate plus she gets an additional pay for each tour given. So from 1 tour to 4 tours and from $33 to $24. So we go from 1 tour to 4 tours, which is a change in 3, and from 33 to 57 is a change in $24. That must mean that she gets $8 per tour. And if we go back 1 and subtract from 1 tour to 0 tours and take $33 minus her $8 per tour, that would mean that she gets $25 for a flat rate. So the equation for Robbie is $10.50 times the number of hours he works, and the equation for May would be $8 times how many tours she gives plus the flat rate of $25. If we were to plug in, let's say, 8 hours for Robbie, he would make $84. If we did, let's say, 6 tours for May, we would get 8 times 6 plus 25, so $73. Slope is the constant between all pairs of points on a given line. Find the y-coordinate when x is equal to -6 on the line that passes through the points 0, 4, and 4, negative. So I can plot my points 0, 4, and the points 4, -2. I can see that the slope means that we're falling from one point to the next is negative down 6 to the right 4, which is equivalent to -3/2, or also equivalent to up 9 to the left 6, as we can see with our triangles. The y-intercept here is at 0, 4. We know that then that the equation of y equals mx plus b is the slope times x plus the y-intercept. So our equation is y equals -3/2 x plus 4. I know that I want my x value to be -6, so I will plug that in for x. Y is equal then to -3/2 times -6 plus 4. Y equals 18/2 plus 4, which is the same as 9 plus 4, so 13. So when my x-coordinate is -6, my y-coordinate is positive 13. And we can see that at the top left of our graph. We just talked about slope and y-intercept. Slope is the constant between all pairs of points on a given line. Determine the equation of the line that passes through the points -4, 14, and the point 1, -11. Well, if I were to draw a line that would create these points, I would see that we have a positive slope here since we're going up and to the right. If I were to draw a triangle so that we can identify what that slope is, I see that I rise 3 units and I run 5 units to get from one point to the other. We're talking about the change in y over the change in x. The y-intercept must be somewhere in between here, which would have to be at 0, -11 and 3/5. So to get there, I would start at -11 and I would go back 1 unit to get from the x value of 1 to 0, and I would have to fall 3/5 of a unit to get to 0. Therefore, my y-intercept is 0 and -11 and 3/5. The equation of this line is y equals 3/5 x minus 11 and 3/5. We can use the fact that the slope is constant between any 2 points on a given line to find an equation of that line in the form of y equals mx plus b, using a little bit of logic and where things are placed on the graph. Math is another language with its own symbols and grammar. To communicate well in math, we must learn to translate words and ideas from the language we know into numbers, expressions, and equations. We're going to translate the following. 3 times the sum of a number n and 6 is equal to 8 more than 4 times that number. Let's start with the left-hand side. We need to take 3 times the sum of some number and 6. So I'm taking the sum of n and 6 and multiplying it by 3. Is equal to, gives us the equal sign. On the right-hand side, 8 more than 4 times that number. More than means to add, so 8 plus 4 times whatever that number is. It's not asking us to solve, it's just asking us to translate. 3/5 of some number n added to 9 is equal to 4 times the sum of that number and 12. So we'll start again on the left-hand side of the is equal to portion. 3/5 of some number n, we're not quite sure what it is, added to 9. So 3/5 n plus 9 is equal to 4 times the sum of that number and 12. So this goes back to the first problem. We want 4 times a certain sum, and that sum is a number and 12. So I want to take 4 times n and 12. The difference of some number n and 15 is equal to the quantity of n added to 7 divided by 2. So the difference of some number n and 15, the difference meaning subtraction, so n minus 15 is equal to the quantity of n added to 7 divided by 2. So the quantity n plus 7, all of it divided by 2. The quotient of some number n and 4 is equal to 3 times the sum of n and 12. The quotient means to divide, so we want to take the division of n and 4 is equal to 3 times the sum of n and 12. So this is like the first two, where we have taking the sum of n plus 12 and multiplying it by 3. Word problems that we translate into equations will have one, none, or infinitely many solutions. Can we write an equation from a solution? What things would you need to consider if you're going to develop your own equations that had one, none, or infinitely many solutions? We know that equations with infinitely many solutions are identical on both sides of the equation, such as 5x plus 3 equals 5x plus 3, or 9 equals 9. We also know that equations with no solution result in a false statement,
such as 3 equals 9, or x plus 4 equals x minus 6. Finally, we know that equations with one solution have a variable on one side and a constant on the other, such as x equals negative 7. Can we write an equation from a solution? Let's start with the following 3 solutions and write equations that would result in each of them. X equals 9, 3x plus 5 equals 3x plus 5, and 7 equals negative 3. Let's start with x equals 9. So this is a one solution. Let's say I add 5 to both sides. That would give me x plus 5 equals 14. And since I did the same to both sides, they are still equivalent. Now let's multiply both sides by 2. 2 times the quantity of x plus 5 is equal to 2 times 14. That would give us 2x plus 10 is equal to 28. We can stop here, or we could keep going, and we have created one out of many different ways for the statement for x equals 9. Let's move to 3x plus 5 equals 3x plus 5, and let's say I subtract 1 from both sides. That would give me 3x plus 4 equals 3x plus 4. Now let's multiply each side by 5. Simplifying would still give me 15x plus 20 equals 15x plus 20. No matter what we do, we will always get the same on both sides of the equation. The same can be said for the false statement. No matter what we do to both sides, when simplified, the answer will still be false. We can use the same operations on expressions as we use with numbers. So on the left and on the right, you see I have the exact same equation. Let's solve it 2 different ways. So let's first start by taking 3x and adding it to both sides, so that I still have 3 times the quantity of 4x plus 2 equal to 12x plus 15. Then let's distribute our 3, giving me 12x plus 6 equals 12x plus 15. When I subtract the 12x from both sides, I see that 6 is equal to 15 is not correct, so this has no solution. Let's do the same thing, only solving it differently on the right-hand side. On the right-hand side, I'll first start by dividing everything by 3. So then the 3 in front of the 4x plus 2 disappears. Negative 3 divided by 3 gives me negative 1x equal to 3x plus 5. Then what I'll do is combine my x's on the left-hand side. So 4x minus 1x is 3x. When I subtract 3x from each side, we get 2 equals 5, which is not a true statement, so this has no solution. So although we did it in 2 different ways, we still end up with the same answer. You may even notice yet another way that we could solve and obtain a no solution. So there are many different ways that we can solve equations. No one is right over the other, just as long as we do the operations appropriately. Use the following equation to write a word problem. Make sure to use the proper mathematical vocabulary and state whether your problem has one, none, or infinitely many solutions. I have 3x plus 5 equals 2x plus 9. So what I first did was subtract 2x from both sides, and I get x plus 5 equals 9. So x equals 9. So now that I have like a context of what the problem is and our ending solution, knowing that we have one solution, we can come up with a word problem to match. Let's write a story problem about riding in a taxi. We could say that one taxi company charges $3 per mile with an additional $5 flat rate. Then another company charges $2 per mile with a $9 flat rate. We could then ask the question, after how many miles would the cost be the same? So then x would represent the value of the miles that we are traveling, and the equal sign represents the cost being the same. So we could find out, since we know that there is one solution, that there would be 9 miles traveled in order for both companies to be the same. A solution to a system of equations is an ordered pair that makes both equations true. Ashley is at the fair with 16 tokens. Games cost 1 token and rides cost 2 tokens. She wants to play twice as many games as rides. How many rides can she go on? So there's a couple different conditions. The first condition is that it's 16 tokens to use at the fair, 1 for a game and 2 tokens per ride. So I'm going to split my 16 tokens into 2 places, 1 token per game and 2 tokens per ride, so that I create an equation of 1G representing game plus 2R for rides equals 16. The second condition is she wants to play twice as many games as rides. So the number of games is twice as many as the number of rides. So games equals 2 times R. So let's see if we can break it down into some tables here to see if we can't find some solutions. So if she plays 10 games, she would then have enough for 3 rides left over. If she played 4 games, she could have 6 rides. And if she did 6 games, she could ride on 5 rides. Let's look at the number of games then. If we choose 2 rides, that would mean she would need 4 games. 3 rides would be 6 games, and 4 rides would be 8. Let's grab one of these and use it as our test point to see if it can satisfy both conditions. So let's try 6 games and 3 rides. So 2 times 3 gives us 6, so it satisfies the number of games that she wants to play. Does it satisfy the number of tokens? So 1 times 6 plus 2 times 3 does not equal 16, since 6 plus 6 is not 16. So let's try a different test point. Let's try 8 games and 4 rides. So 2 times 4 is 8, so it satisfies the number of games. Does it satisfy the tokens that she has? So 1 times 8 plus 2 times 4 is 8 plus 8, so 16. So she can play 8 games and ride 4 rides, and it satisfies both conditions. How can you take 4 inches and make 2 segments where one segment is 1 inch longer? So our first condition is that we have 2 numbers that have a sum of 4. So x plus y equals 4. We don't know what those 2 numbers are. The second condition is that they have to have a difference. So when I subtract them, we get 1. Let's try our test point 3 and 1. So when I plug 3 and 1 as my test points, 3 plus 1 is 4, but 3 minus 1, when I take the difference, is equal to 2. So those won't work. Let's try 2 and 2, because I know 2 plus 2 is 4, but 2 minus 2 is not 0. So maybe let's try a decimal. So 2.5 plus 1.5 is 4, and when I subtract 2.5 minus 1.5, I get 1. So 2.5 and 1.5 are my solutions. So if an ordered pair substituted in both equations makes both equations true, it is a solution. Use a graph and the following clues to determine which hikers meet on the trail. They all departed the parking lots at the same time. The Welcome Center is 900 yards from parking 1 and 720 yards from parking 2. Ashley and Michael leave parking 2 and travel at 60 yards per minute. May leaves parking 1 and travels at 90 yards per minute. And Mr. Nelson leaves parking 1 and travels at 60 yards per minute. So we know that I've got our line graph at the bottom there. 900 is where we need to go, and the distances between parking lots 1 and 2 and their overall distance to the final part, to the Welcome Center. Michael and Ashley are traveling together, so they have a head start on location than the rest with Mr.
Nelson, May, and May. So they're at 180-yard advantage. So then after the first 2 minutes, Mr. Nelson travels 60 plus 60 per minute, so 120 yards. May travels 90 and 90, so 180 yards in 2 minutes. And then Michael and Ashley travel 60 yards per minute, so 180 plus 120 gives us 300. So following in our path, doubling Mr. Nelson and May for another 2 minutes and adding 120 for Ashley and Michael, I see that May is quickly approaching Michael and Ashley, but Mr. Nelson is still far behind. At 6 minutes, I see that Mr. Nelson has traveled another 120 yards, while May has finally caught up to Michael and Ashley and will now surpass them because she's walking a little bit faster. She's traveling 30 yards per minute faster than Ashley and Michael. So now she's overtaken them at 8 minutes, where Mr. Nelson is still behind. So we can write an equation for each one of their travelings. Michael and Ashley travel at a rate of 180 plus 60 yards per minute, where T is time. May leaves parking lot 1 and she's traveling 90 yards per minute, so per minute, so times time. And then Mr. Nelson is traveling at 60 yards per minute. So converting these into a graph, I see that Mr. Nelson, who is this green line, will never catch up or intersect with Ashley and Michael or May. I see that this blue line is Ashley and Michael since they have a head start at 180 and they're traveling. And then finally May will surpass them. Their paths are marked off and the location where they intersect is where Ashley and Michael meet May. The graph and equations represent how much water remains, G, in two fountains during the time in minutes they are being drained. Fountain A is at a rate of 250 minus 25 T, and fountain B is being drained at 220 minus 20 T. Classify each statement as true or false. Assume the fountains begin draining at the same time. Pause the video and answer true or false, and then we'll talk about them. Fountain A has more water remaining than fountain B until they are both drained completely. This is false. At one point in time, fountain A will have less water remaining because where they intersect here, then all of a sudden, as we move forward, fountain A starts to have less water than fountain B. Fountain B drains at a faster rate of gallons per minute than fountain A. This is false. I can see above that fountain B is draining at 20 gallons per minute, where fountain A is going at 25 gallons per minute. So it is draining, fountain A is draining faster, has a faster rate. The fountains will have the same amount of water at 6 minutes. So at 6 minutes, I see this is where they intersect. So this is true. When fountain A has 100 gallons of water, fountain B has 100 gallons of water. That is true. Where they intersect at 6 minutes, they both have 100 gallons of water remaining. We can solve systems of equations algebraically as well as graphically. Let's say we know the price of a pepperoni pizza is $1.25 more than the price of a cheese pizza. Let's use a system of equations to finish this purchase order. Let's let P equal the price of a pepperoni pizza and C be the price of a cheese pizza. Here we have 14 pepperonis, 16 cheese for a total of 20 pizzas. We don't know their price per unit, but we do know that it costs us altogether $242.50. So here are some things we know.
The price of a pepperoni pizza is whatever the price of a cheese pizza more than or plus $1.25. We also know that 14 pepperoni pizzas plus the cost of 6 cheese pizzas has to equal $242.50. Since I know what P is, I can put in C plus 125 where I see P in the second equation. So 14 times $1.25 plus C is equal to 6C, which are plus 6C equals 242.50. I can distribute the 14, giving me 1750 plus 14C plus 6C equals 242.50. Combining like terms, I have 20C plus 1750 equals 242.50. Subtract 1750 from both sides gives me 20C equal to 225. Divide by 20, C equals 11.25. So a cheese pizza is $11.25. We can then find what a pepperoni pizza is by inputting 11.25 into the pepperoni equation. So pepperoni is equal to 11.25 plus $1.25. So a pepperoni pizza is $12.50. We now can finish our chart. Because we know that a pepperoni pizza is $12.50, a cheese pizza is $11.25, so altogether would be $23.75. I can then figure out my subtotal category by taking 14 times $12.50 for $175, 6 times $11.25 for $67.50, and adding each subtotal in each subcategory. I can see that altogether we balance out at $242.50. A movie rental company offers two options for its customers. The digital movie option costs a monthly fee of $3 per online rental. The DVD option costs a monthly fee of $10.50 per rental. When will their options be the same and at what cost? Let's let X represent a movie rental. I know that then for the online rental it costs 3 times X and that the DVD option is the base fee of $10 plus 50 cents per movie. I want to know when these options will be the same, so I will set them equal to each other. I will subtract 50 cents times X from each side, giving me 250X equal to 10, divide by $2.50, so X equals 4. The two options will be the same when I plug 4 into each option. So when we rent 4 movies, and the total cost then would be 3 times 4 or $12, which is the same cost at 10, the base fee of 10 plus 50 cents for 4 movies. The options will be the same, renting 4 movies at a cost of $12.